Now let's think about logarithmic functions. This is kind of the opposite. In fact, it's called the inverse function of the exponential functions that we were just looking at. So let's just look at a couple of examples of those and have a little think about them. So first of all, how about the logarithm in base 10 of x? And let's do that between 1 and 10. So that means that for every x, we need to take the log in base 10 of that number. So doing between 1 and 10, I'm just going to take a few to help us sketch the graph here. So we're going to take the log in base 10 of 1, which is 0. Log in base 10 of 2 is 0.301. Log in base 10 of 3 is 0.477. 5 gives us 0.699. Hopefully these numbers are becoming slightly familiar to you from all the different exercises you've been doing. 0.845, and then finally log in base 10 of 10 is 1. So let's draw the graph. So we're going, our x is going up to 10. And our y-axis needs to go up to 1. Something like that. Okay, so our first point is here. So right down on the x-axis. 2, 0.31, something like that. 3, 4, 7, something like that, let's say. 0.45, should we say that? And final point, something like that. So our line is making a curve like that. And if we carried on below 1, so for example, the logarithm of 0.1 is -1, so our line is going to continue like this. But this is the domain of what we're doing right now. Good. So now let's think about a second function. Let's think about natural logs and plot those out. So this is logs in base e, and we're going to do for this same domain. Okay, so so here the x, we're taking the log in base e of x, and e is about 2.718, etc., etc. Cool. So 1 gives us natural log of 1, which is 0. 2 gives us the natural log of 2, which is 0.693. 3 gives us the natural log of 3, which is 1.099. 4, we're not going to bother with. 5 gives us the natural log of 5, which is 1.609. 7 gives us the natural log of 7, which is 1.946. And 10 gives us the natural log of 10, which is 2.303. So let's draw those out. So you'll see the scales we need to use are different. So our x still goes up to 10. But here we only need, I'm going to go up, here we need to go up to 3. Right, so if we start drawing these on the graph, something like that. Something like that. And again, if we start going lower, then our line will continue below the axis, but here we're just looking at this part. Okay, so you can see that there's this point is the same, and this is the intersection of all the different logarithmic functions, because the log in any base of 1 is equal to 0. So let's draw. So this line is for, and let's add the line in base 10 onto this same graph. So that looks something like this. Okay, so all the logarithmic functions will intersect at this point. So that's something you need to remember. But the base of the logarithm that you're in will affect the shape of your function.